Is there a photo of me on your wall in shorts or sit-down jeans? Do you look up at night and wish you were me? Another spotlight. Are you visceral? Do you wanna make love to my sweet visage and then pretend it's you, it's always you. Wrote you a letter to become a member of your fan club. All I got in the mail was return to I'm still a big star. No, you're not. Yes, I am. No, you're not. Yes, I am. No, you're not. You like my latest film? No, I didn't. Yes, you did. No, I didn't. Yes, you did. No, I didn't. I'm not a fan of yours anymore. Yes, you are. No, I'm not. Yes, you are. No, I'm not. Yes, you are. But you broke my fragile heart. Yes, you did. Yes, you did.
All right. Hi. Thin crowd today, 23 people. All right, what's going on? What questions you got for me? Samin.
Hi. So I had a question on the guide for this week's lecture in lecture number 8.
Mm-hmm.
In the check-in exercises,
Yeah.
I was just confused about the last question in that one.
Nucleon, proton. Okay.
Yeah. So I was
Interesting.
just
Still
confused.
there. Okay, go ahead.
Yeah, so I thought like if it's like static and dynamic type is both like a proton,
Mm-hmm.
then I was just wondering like why it would look in like the parent class, or if it always looks in the parent class if it can't find like a matching signature.
Got it. All right. So let's see. Let me do the side by side. And okay, I'm gonna just try something out here. I'm not sharing my screen. Okay, so let's grab these lecture slides. I'm gonna try and work it out exactly parallel to the way that I do it in lecture and see what happens. Thanks for asking this. It's funny because we were debating this problem, this nucleon code, because it's very weird. It's not how I would recommend writing code ever. Let's see. Sorry. All right. So what we got is, okay. Okay, I'm going to copy and paste stuff from, oh, I can't copy it because it's an image. Okay, hold on. Holding interface nuclear. How can I get access to retype it? That's dumb, but I'm going to. Okay, sorry. I'm going to share my whole screen. You can watch me retype code from the screen. Okay, public interface, nucleon, default, oops, Java file. Other, print line, nucleon, default collide, nucleon, other, system, it'll be worth it. Public class, proton, implements nucleon, public void collide. Nucleon other, start out at print line, proton, nucleon. Alrighty, we did it. And then we're gonna have P equals new proton. So I'm gonna grab all of this and make a little slide out of it. Okay, it's ugly, but smaller. Okay. Fun. Okay, after all that, now I think we'll be in good shape. Okay, so then we want to copy this other code, which is proton P equals new proton P dot collide P. Is that right?
Yeah, that's right.
Okay, cool. So keeping with the trend of what I did in the other lecture, I'm going to copy and paste the default method in here and mark it in gray. It's going to be my first step. I do that, and it looks something like this. Okay. And this is overwriting. So I'm going to add that just to be really explicit. It's not there in the code, but it is overwriting, right? Okay. So deciding which method is going to get run is a two-step process, as we know. So let's do step 1 first. What's the first step? What happens? Like, so we use, so at compile time, we pick a signature S. So what signature do you think we'll pick?
Because it's type proton,
Huh?
then you'd pick the signature in the proton class.
Right, so we're gonna look over here to decide which one to use. So here's 2 methods we can pick from. Which one's the better choice?
So does it depend on what the parameters are? Like if it's
Yeah.
taking in a proton?
Yeah.
Oh, okay.
Yeah.
So then it'll be the default method.
Right, so it wants this one. So this is the best choice. Right, so in other words, the best match for collide proton in type, we look in class proton because static type of invoking object is proton. And then the best method, or like the matching method in proton is collide proton. Does that make sense?
Yeah.
So that's the hard step. The other step's easy. The other step is, let me just do it explicitly because I really want to parallel lecture as absolutely closely as possible. So then step 2 is at runtime, we pick which collide proton. And so in this case, though, there's only one collide proton. So the choice is just, or sorry, I'll be less wishy-washy. I will say the dynamic type of P is proton. So we use proton's collide proton method, which is inherited. Sound good?
Yeah.
Okay, so that's why it's this right here.
Okay.
Make sense? Yeah.
Yeah, that makes sense. And just like one more really quick question.
Sure.
So like when you're like declaring, like if I were to say like this is like another one of your examples, but if I was like casting a type at instantiation, like let's say I had like
Mhm.
bird equals new falcon,
Mhm.
and then on the next line I said falcon equals a cast
Okay,
of falcon.
so I'll note just real quick for people who are watching this or who are here live, there's a lecture 9 topic, but let's do it anyway. So lecture 9 casting question, right? Because it's not in lecture 8, correct?
I'm not sure. I was just looking at an online like test, I think, or
Got it,
something.
okay. Do you have prior Java experience? Like, have you seen casting somewhere?
Yeah, in my I think high school class.
Okay, cool. Sounds good. But just be aware there's a lecture 9 question. But go ahead. So if I have Falcon,
Falcon,
yeah,
like lowercase, yeah, equals, or sorry, the first line is bird equals new falcon,
yeah,
and then the second line is falcon equals like a cast of falcon, like parentheses,
Uh-huh.
and then bird.
right. Okay.
So is the dynamic type for this for the second falcon, for the falcon object, going to be of type falcon?
Let's see. It is of type Falcon, and the reason is, I'm going to say it's Falcon because of line 1, right here, this thing, because it's like what was instantiated.
Yeah, falcon. So the for line 1 is the static type of bird and the dynamic type of falcon. Am I understanding it correctly or no?
Right. So if I were to do that same little diagram, I'm going to grab it from later in lecture. Where's my cool little box? So casting, again, not something you've seen yet, but so don't worry too much about that syntax. Those of you who are wondering what the heck this thing is. So in this case, here's bird. Here is falcon. And let's fill in all the stuff. So what is the static type of bird?
It's bird,
Bird, right? And what's its dynamic type?
falcon.
Right. Okay. Because we said new falcon. How about falcon?
It's falcon static
Yeah.
type.
Yeah.
And then the dynamic, because the last one would be falcon.
Right. And so if I go up here and I'm going to make a note that this is actually bird, it can only ever hold a bird reference.
Okay, so what if like there was no cast there? Then
Right,
what
so
would
if we
the
do
dynamic
this,
type be? Yeah.
this would crash. So if we did falcon equals bird, the code would fail. And not all birds are falcons. So you can't do it.
Okay. Okay.
All right,
Thank you.
let me give you a related question. Let's say that I did bird here. What does that do? And I'm asking you something we haven't covered in lecture yet. Does this change any static or dynamic type of anything?
Would it be of dynamic type bird?
Nope, it's still a falcon because it was created as a falcon. Like think of this, a falcon has a bunch of instance variables. Maybe falcons have like favorite roosting spot, right? And it's an instance variable. Just because you cast it as a bird doesn't make that variable go away.
Okay.
So this doesn't change any types.
I thought so the type at instantiation or the type of declaration is a static type and the type of instantiation is a
Correct.
dynamic type. Oh,
Yeah.
okay. So that's why the dynamic type is falcon.
Right. In fact, a cast doesn't change anything. It never changes anything.
Okay.
What I think about a cast, as I'll say in lecture 9, is it tells the compiler, don't do your normal type checking. I know what I'm doing. It doesn't actually change anything. It just says, for the purposes of type checking, pretend this is a bird.
Okay.
Yeah.
All right,
Which
thank you.
doesn't require much imagination since falcons are, birds. Will a study guide be released for the upcoming midterm? Like an explicit study guide? No, but in each lecture we have study guides. So yeah, it's just the concatenation of all these. But there's not a single study guide. All right, Simi, wait, that was me. All right, Dana.
Yeah, hi. So I was looking under the resources tab first on the course website, and I was looking at midterm 1 review Gorilla section under the midterm 1 spring 2018. And for the last question, I think it was question 8, part B or 8.2. I was just wondering how you would like approach the rotate one.
Rotate,
yeah, so
right,
2.
okay.
8.2, sorry. Yeah,
Right, okay, so first of all,
wondering-
destructively is a term we don't use this semester. So do you know what that means, I guess? First question.
Just like altering the array, like
Yeah, in place. Okay, just want to make sure
permanently.
that's very clear. It's not a term I introduced because we rarely use it in the rest of the class. Okay, so how would we approach this?
Yeah.
Yeah, that seems tricky. I would probably start with a 3x3 and then I would like write something out on paper. So let's try and do it. I'll do it in Notepad or in Paintbrush. I'm going to do this as lazily as possible, like just trying to stumble on the solution. Let's say I have 1, 2, 3. Oops. So the first thing I'll do is I will, to make sure I understand exactly what's going on, I'm going to work one out by hand. So this is rotate. And we didn't really talk about 2D arrays very carefully in class. So this adds a little extra difficulty. But so we turn it 90 degrees clockwise. Then everything is going that way. Okay. So if we're rotating this over, this becomes 1, 2, 3, right? Is that right? Sorry, why is my brain not working?
Yeah, I think it's
Hold on. 1, 2, 3. Yeah. Okay. So that gets rotated there. 4, 5, 6. Yes, right. 7, 8, 9. All right. So that's what we got to do. Okay, interesting. So being lazy about this, what do I want to do? I guess I'll note that, okay, so basically my next thought is I need to have some kind of mapping between like my original row and my target row, and my original column and my target column. And then I would probably write 2 helper functions that do that. So to do that, I don't know, what do you think? How do we? So basically what I want to write is R90 row, and you give me an R and a C, and it gives you back the row. And then, I mean, this is the laziest thing I would imagine trying to do. And I do R90 column. Like I'm in a hurry. I have to do it in the next 20 minutes. And I don't want to be elegant or clever. I just want to like get it working and feel comfortable it'll work. I see some discussions in chat. Let's see. Right, okay. So I would probably start trying to work out some little examples here. And I would say, well, okay, so if let's give a row and column ordering. So let's say this is R and C, and this is, sorry, like this position. I'm going to do a different color here. This is 0, 0, and this is 0, 2. Okay, so I'm going to make myself a little table because when I'm trying to understand the function and I really want to get it right, and I find it helpful just to write out some input-output pairs, right? Because I'm building a function that's going to do this. So here's RC, and let's call this R, I don't know, prime. We'll call this C prime. So what I would do next is I would write out some examples to try and divine the pattern. Are you following me so far?
Yeah.
So basically, my steps were 1, try something out. 2, think, well, really what I'm trying to do is understand how to get the new row and column number. And I'll have to be able to use that somehow. So let's say the original row is 0 and the original column is 0. What's the new row prime?
0, 2.
Right. I'm only doing the R. I'm trying to keep myself very simple. So what's just the new R prime, not the C prime?
Oh wait, so then it's just 0 then?
Right. Okay.
Still?
Yeah. So we got 0. Okay. So then what if this is me being as absolutely lazy as possible. I'm just gonna like render it into very concrete terms. So then if it's row 0, column 1, what's R prime gonna be? So that's this 2.
Row 1, column 2.
Row 1, column 2, right, yeah. But I'm only doing the row again because I'm super lazy. I don't want to think too much. Because thinking means I can make mistakes. All right, then if it's row 0, column 2, then the row prime will become 2. Okay, oops, 2. Okay, so basically I just like recorded the fact that this goes here, and this goes into this row. Okay, now I'm gonna see if it seems like, oh, well, maybe I'm starting to see a pattern here. Let's try the next one. It's the same basic idea hold. If I'm in row 1 and in column 0, let's see, where do I end up? Oh, I end up in position, I end up a row up. So I end up in row 0, right? I'm at 1, 1, I stay in the same place. If I'm the number 6 right here, I end up in row 2. Okay, 0, 1, 2, 0, 1, 2. I'm starting to sense a pattern. Just for symmetry reasons, it seems inconceivable it's not just going to be the same pattern, and indeed it's the same thing, right? I do 2, 1, 1, 2. Okay, I have now written this function, right? I know how to write it. What do I do?
You just have to translate all of the rows into the 0, 1, 2 pattern.
Yeah, so what do I do? Like this function here, given an R and a C, what's the relationship between R, C, and R prime?
Wait, what do you mean by relationships?
So if I tell you an R and a C, what is R prime going to be?
It's always going to be, so if it's 0, it's always going to be 0. Oh, So for the first like column, it's going to correspond to 0, and then second column is going to correspond to 1, and then
right. So how can we write that in code? Basically, you give me R and C. What should I return? So if I give you 1, 2, what should you give me?
Just 2 then.
Right. So what's the more general rule? Like these are the
Oh
two.
wait, you would just return the column, right?
Right, exactly. Okay.
Okay.
It seems like the new
Sorry.
row is just the column, right? Now, does that pattern hold for the other? Maybe, maybe not. We could try and be smart, but why be smart when you can be lazy? Let's do the same exercise now with C prime. Right. Those of you who want to use geometric reasoning or whatever, sorry, not doing it. I don't want to do it because that's too clever. All right. So let's write the steps. I'm going to rewrite these in purple. Okay, so if we think about what the new column is going to be, same exact exercise, where I guess I'll do orange. If I was originally in row 0, column 0, I end up in what column?
The 2 or
right.
the 3rd column.
Yeah, so we're in column 2, right? Ah, that's interesting. So you might have thought, well, maybe I'm just switching the rows and the columns. Like maybe this function would just be return R, but that would be transposing the matrix. So it's something else. So let's see. Next up then, if I'm in row 0, column 1, which would be here, where do I end up? What column?
The last column.
Right, 2 again. All right, how about 0, 2?
Yeah, same last column.
All right, cool. What do you think these are going to be?
That's probably going to be the column 1, and then the last one is 0.
Right. Okay. So what's the pattern? What's the function? So I want to come up with C prime from R and C.
So then it would be like say that n is like your column length, or your column
size.
Size, and then you'd just be n minus 1 minus like whatever row you're on.
Right. Yeah. So we could just do like R dot length. Let's call it n. We can compute that. So it's n minus 1 minus R. Sure. Okay. Great. So that's one way to do it. There are other ways to do it. You can do things with matrix multiplication. I don't know. There's other dumb things you can do. But this is the absolutely most foolproof way to approach a solution. So once I have these two functions, then it's just a matter of doing the following. That the new array, like the thing we're rotating. Oh, so we need to do it in place though. So it's destructively. Ah, man. So I was trying to be real clever. Well, all right. I could do something lazy. It didn't say I can't make new ones. So maybe there's a more clever thing. I'm just trying to do this as lazily as possible. So this is going to be the R copy. And then I would just go through and I would say something like, do I have the right direction for my functions? I want to say it's equal to, I know, is it always going to be a matrix? N by n, right? So I know n, let's just say. New int n. So you asked me how I would approach it, not what the best answer is, by the way. And so this right here, I get an array, and then it's just a matter of copying everything using my function. So I say for R equals 0, less than n. For C equals 0, C less than n, and then I just say R copy. Actually, I'll do a help from a function call first. I'll do R prime equals C prime equals. We already have the functions over there. And then I'll just do, wow, my hand's getting tired from trying to write with a mouse. This is terrible. R prime, C prime. All right, I'm running out of hand units. Equals, what's this thing called? RC. Okay. And then I guess I would copy it back to R because I'm real lazy. That's the way I would do it if I was just trying to get it working and I didn't want to get it wrong at all. So then I would have a second for loop to copy back to the original one so that it's destructive. Happy with that?
Yeah, that makes sense. Thank you so much.
You got it. Okay. Somebody have a thought? I'm gonna sit in the chat. Anybody mad about it? Okay. Yes. Okay. So if we don't do a copy, how would this work? I'm trying to think about this. It's a little tricky because if I'm not willing to create a new matrix, then anytime I write something, I need to like have a temporary variable. That is, if I start with 1, 2, 3, 4, 5, 6, 7, 8, 9, and I move the 1 here, then I have to displace the 3. So that's a little weird. Let's see.
No, yeah, because like originally I was looking at the solution and it just seemed really unintuitive, but that's how they were doing it, like what you just described. So
They didn't create a new matrix.
they were just in place swapping. So
they did some in-place swapping, right? So in-place swapping then is a little more challenging because you would have to. I mean, one way to do it is to have this function and its inverse, and then basically say I'm going to take item 1 and then put it in R prime C prime, and then wherever I end up, then I have to replace that value, and then I will figure out like if I back rotate to the left, where would that supposed to be? I guess. Or no, is that right? 1, 3. Hold on. 1 goes here. Oh, so then I need to put 9 in its location. Oh, no, wait, you don't have to have the inverse of the function. Sorry, what am I talking about? You would take 1, you would put it here, and then say, oh, I need to put 9 in its appropriate location. And then you would compute R prime and C prime for 9, and you find it's supposed to go here. And then you take 7, and you would just basically iterate over the array in this funny way. So basically, just like we did, instead of going like row by row, it would just be using these same helper functions, but filling it in bit by bit. That's how I would do it if I don't want to use space. There may be an even more clever way of doing it than having these helper functions, but that's the lazy way that I came up with. Will we have to worry about creating in-place or destructive methods? So it is entirely conceivable that we would say, you may not create a new object. You need to do this with only the object you have. Just because it's a programming challenge. There's nothing special about it compared to any other programming thing you might do. So for that reason, I wouldn't say that it's out of scope, right? I don't know that it's I guess there is a way you can kind of practice that way of thinking, but I don't really think of it as like something so fundamentally different that it would be in or out of scope. Yeah. I'm curious what the solution looks like. This is a cool question. Okay. Oh, yes, that's what they're doing, right? Temp RIJ R. So how do they avoid? They're iterating over the original array in row order. I mean, you can see the formula that we came up with in there. Oh, they do 4 swaps at once. Yes, okay, that's what they're doing. So I had a different idea in mind, which was basically like taking them one by one and kind of hopping all over. But there's some reason that doing 4 at a time works better. And someone linked something in the chat. That's interesting. Why is it 4 swaps at a time? Is that just something you saw in the code, or is there some like clever reason? Yeah, go ahead, Daniel.
I think it's 4 because the way that they're thinking about it is that when you rotate 90 degrees, like think of it in terms of like the first, like the corners first, so that it's a bit simpler. You'd be putting 9 where 7 is, 7 where 1 is where 3 is, and where 3 is where
I see.
9 is.
Right. Okay.
Yeah.
So that's the big idea. Oh, that's cool. So you kind of have these like 2. Interesting. I like that a lot. Yeah. So as I
And
said
so
earlier, you can apply geometric reasoning or like being a little more clever. I just didn't want to. So notice that these 4 here, they all move together, right? So that's the observation that leads to this swapping 4 at a time. So how does that generalize to larger matrices? What does it look like? It's like, I kind of write this thing out. One sec. I'm gonna paint window. I have a matrix. That's fun. I hadn't thought about that, or at least not in a long time. There were no other questions in chat at the moment, so I'm gonna do it. Let's see, so I got, I'm gonna do a 5 by 5. And I want to see this 4 thing. Okay. So in that case, it would be like corner, 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 corner. Then you'd have this, 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 right? Is that right? Yeah. I'm feeling pretty good about this. This one, this one, this one, this one. Okay, I see what they're getting at. But you know, that's awfully clever. And I don't think anybody would do it that way in 61B unless they had, you know, pretty good math background. It's fun.
The one on the row 2, column 0 is 1 down.
Oh, 1 down. Yes, thank you. Right there, right? Now I want to draw the whole diagram. This is cool. This is a really interesting symmetry thing. Oh, I love this. What is this thing called? This graph? Anybody know? Can I make more of them? I love this so much. I got the degenerate singleton case in the middle. Oh man. Now I want to write some code that generates this. That is so cool. Huh. All right. I feel like I need to see a 3 brown, 1 blue video about that. Neat. Thank you. That ruled. Thank you. I had the colors backwards. Yeah. Oh, recursive in some way. Yeah. Oh, you're right. Matrix multiplication won't be. Is there an in-place matrix multiplication algorithm for multiplying a matrix by a specific, like a rotation matrix? I don't know. Anyway, I don't know. I'm going to weird territory. Yeah. Yeah, exactly. I mean, of course, we can apply if we have the right matrix, you can just multiply by the right identity matrix and get a rotation too. Though it's the way I would approach it in 61B, it would be none of that. It would be this extremely lazy approach. But I love the big brain, this thing approach. Oh, it's so good. Yeah. Anyway, cool. Sines and cosines of the angle. That's funny. All right. Yeah. Okay, what's next? That's an amazing question. I love that. That was fun. Oh, this approach, this one where we do this thing and rotate. What does the diagram look like for non-squares? I will leave this as an exercise for the viewer. I suspect that a similar diagram exists and it's still based on 4s. But it won't be quite as nice. Let's see, what is it? The thing is, your new matrix is going to be sideways from where you were before. Well, I'm going to do it. I'm going to do it. I'm sorry, I'm too curious. So let's do the diagram for like a 2 by 5 or something. Okay, let's see. So if we have a 2 by 5. We rotate it to the right. Yeah, exactly. I was thinking about Rubik's Cubes, by the way. This is very similar. Oh, I gotta write these out, so then I have. Okay, so this is up here. No, it's up here. This. So is there a 4 thing? Or it's like the number change? Huh. If you wanted to, well, you can't do it in place, obviously, because you have a different shape. But I still, is there some diagram? Like, so whereas with a square matrix, so in a square matrix, we have size 4 sets, right, of identical color, where a color indicates a set of items that can be simul-swapped in place. And there's probably some deeper mathematical way, but at least in terms of 61B, say you swap them all at once. That's like a 4-way swap. So I conjecture, maybe in a non-square matrix, if you flip the interpretation of your matrix so that rows become columns and vice versa, then we have different size sets. Oh, let me try and work it out. Oh yeah, tilt method. I like that too. Okay, so I'm going a little meta here. I can't do the square thing because the size isn't the same, but if we flip our viewing perspective, I don't know, I feel like I'm going off into territory that maybe nobody's following me into, but like if this is a thinking bubble, if this matrix is imagining itself, or sorry, this n by m here is thinking about itself as being, it was a matrix, sorry. If this matrix is thinking about itself as being sideways, well, I have to decide which way it's rotated. I feel like it's just tautological. All right, I don't know where I'm going. Yeah, all right. No, I think my conjecture is garbage. And I think that in an n by m, there's not really anything here. But is there? I don't know. All right, I like this though. This is cool. Okay, what else do you want to know? I used to be really, 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 really good at linear algebra. It was a great superpower to have for a while. But... Okay, next question about 61B.
I was just quickly curious what lectures would be in scope for the test.
Yeah, sorry, and it will be everything up through 8.
Perfect,
We need to
appreciate
broadcast
it.
the information better.
I feel like that's probably gonna come once our.
Yeah, I could have looked it up, but nobody was asking a question, so I went the lazy approach like you just taught us.
Yeah, sounds good. At this, in a 25-person setting where we're just talking, that seems perfect. Next. Daniel.
Yeah, I was wondering, when we have like a Java class that has another class inside of it, is the purpose of that to avoid overloading or not overloading, but like I guess, the problem of overwriting, or is that
I
more
don't think it
of a
has anything to do
stylistic?
actually with overloading or overwriting. I think it just has more to do with organization. So that if you have an S-list class, for example, it makes sense to have a node class inside S-list that's just hidden, because like a node is just an implementation detail of an S-list. But I don't really think of it as having any real interaction with overriding or overloading.
Okay.
When I'm not doing implementation.
On that note, real quick, are those supposed to be protected? Because I was getting yelled at when I made them public, and obviously we couldn't make them private for like the variables inside Node.
Right. Wait, why couldn't you make them private?
Because then I couldn't access something.
Au contraire, though. So inner classes are sort of funny, or nested classes are funny, and that they enclosing class is considered to be part of the private club. So if you make them private, you will still be able to access them.
Oh, okay.
Yeah.
For some reason I think I broke it, but I guess it was something
Okay.
else I broke.
Yeah. No need to do. Protected's a wholly different thing we won't cover, but as you observed, it's stronger than public, but weaker than private. What's next?
This might be like stylistically bad, but what if we had like a general interface that was like node,
Mhm.
and the inner class like int node implemented a node? How would that interact with the outer class that the inlet
Sure,
node was
just to see what
inside?
happens. Let's try it. Let me open up lecture code repo. Let me share my screen. Okay. Oh, someone asked about the text editor for the midterm. It's all going to be in browser text editor. That's an interesting question. Can you use an external one? I don't know that we set a rule about that or not. You certainly shouldn't be opening IntelliJ, but that's a really interesting question. Like if you want to use Sublime because it's prettier or it has like convenient features, I don't know. Yeah, ask on Ed. We'll discuss. So the question was, if we have an S-list, this private class here. So you're saying, what if we create an interface here within it, like an inner interface? Is that right?
Or
Nick?
like not inside of it, but like as a
its
separate
own thing.
file.
Right. Okay. So if we do that, I think what we'll find is this is not very useful. But let's find out. Oops. I'll make a node class. Oh, I want to make an interface actually. Okay, so it's an interface that does what? What does it have in it? Nothing really. But I made one. Something like that.
Yeah, something like that.
Yeah, it seems to have no effect. It's just like it implements some interface that's empty. Keep in mind our node class is very dumb. Like there's no methods. No, so there's nothing to put in here.
Right.
Yeah.
If it had methods inside like the inner class, so
Right,
inside,
so let's create one. Let's say default public, just for the heck of it. I don't know what it would mean, but default public void print. Why is it yelling at me? Oh, it's not default, sorry. It just says public void print. And then this overrided print. Oops. I've done this so far. What else do you want me to change, if anything?
so I guess what I was wondering was like in the context of an SL list, since we have access to the methods of
Mhm.
just stuff node,
Yeah.
If we execute a method in stuff node, will it go through the same rules as if we were like in terms of overloading and overwriting as we
Right.
would
Oh, I
in-
see what you're saying. Yeah, surely it will. Yeah. So if I have like a default public void print, and then I do system.out.println hi. Wait, why is it yelling at me? Oh, because I did the wrong brackets. Weird. So here, default public void print. Yeah. So if I were to create stuff nodes and then be calling print on them, then it would absolutely be using all the same rules from before. Hope that answers the question.
Yeah.
You are not allowed to use the Java visualizer. In fact, you're not allowed to compile or run code on the midterm, for reasons I mentioned in an earlier thing like this, that if I give students the freedom to actually compile or run their code or even compile their code, it gets people just stuck on problems where they would be, like people will spend, like just anecdotally from other people I know that teach, that people will spend a half hour trying to debug some small thing that isn't really worth much credit instead of moving on. But one day I may, as I mentioned, have the boldness to actually have a programming exam, but not right now. Well, that's next. Got 4 minutes. Ha. Yeah, right. 10 hours debugging a misspelled variable name. Boy, ha. Yeah. "61A exams allowed you to compile and run code mid-exam." Interesting. Mid-exam. All right. I'm too scared. Maybe sometime in the future, but yeah. I'll have to ask John what they did. Yeah, my main studying tip and advice for the midterm is to get that project checkpoint done. Let's do today, because it's just, we haven't covered all that much. So this midterm is meant to be like an early signal that like, okay, yeah, I'm really on track to like succeed in the class and course correct if you're not. Keeping in mind we have a clobber policy for anybody that's like a little behind, because and it's not about Java syntax, because that's not fun, and the people who knew Java already would have a huge leg up. So it's more about like, problem solving in the context of lists and arrays. The other one is, of course, doing practice midterms. Though we're doing this midterm a week earlier than before, so yeah. It's an interesting thought. So maybe it's a thing worth doing in the future. But I don't have the confidence to run an exam well. I've run exams so you can't run code for years, and they generally work pretty well. People aren't too grumpy about it. But yeah. I'll say this: like, I don't like writing exams like fidgety, like you got to call the ceiling function in just the right way, whatever, right? So, yeah. Go ahead. Someone was going to say something.
I was wondering for extra credit, is it like, I think somewhere or like sometimes it mentions like 1 or 2 points of extra credit. Is that like in the context of the overall point system
Oh, yeah.
or score?
Yeah, the 2
Okay.
points for Project Zero were very little out of 12,000. That was partially my reticence to significantly reward people who finished early, because I don't know that it's really reflective of greater understanding so much as prior preparation for knowing Java already for Project Zero. The other points, though, are calibrated to match the past, so they're bigger by a factor of a lot more. So there's 16 points for checkpoints, 32 for the extra credit things. Still not a ton of points, but that's just because I really don't want the class to too heavily bias itself towards success just if you happen to come in knowing a lot of Java beforehand. So yeah, sorry. I know my class is just like ruthlessly exam heavy in terms of points, but it seems like the most equitable thing to do. Does the point total double every semester? It has so far. See what happens. I had a TA rebellion about it this time for the first time, but yeah. But I've come up from 230 points. That's where we started. So it's like watching time go by, you know. It's like yeah, I know. We worked out the year where we run into trouble. It'll be a while. Yeah. I think this is the last semester where it's gonna seem like vaguely reasonable. But once we get to, you know, like 60,000 points, 50,000 points for the class, I don't know. We already had people complaining last semester. This time at least it's like close to a, you know, 10,000. So, all right, we'll see how it goes. Yeah, I'm gonna run. I got more meetings. Today was a crazy day for me, by the way. 9 a.m. meeting was my first one. Last at 4 p.m. straight. So, you know. All right, see you on Monday. Good luck on project 1 if you're not done with the checkpoint yet. See ya.